How long have you been in this space, Mithun? How long have you been working really around NLP in general?
In early 2000, right? So that's when we started working on the core NLP, which is to create processing of textual data, creation of actionable knowledge or semantic knowledge, as we call it. Also coincides very well with the advent of the semantic web in 2000 and creation of standards like the W3C's RDF, RDFS, OWL standards, which all created the framework required for pushing and representation of knowledge, right? So that's where the big hole was. Now, let's say you have a document that is all textual data, natural language data that humans love to communicate, and that's the most effective way for humans to communicate is textual data. However, for a machine, that's hard to understand because there's a lot of ambiguity. There's a lot of concepts that are really not required, and you cannot focus on the real knowledge, the actionable knowledge. So an ontology helps there. And a representation of the ontology was a thing that the community could not agree on. So W3C coming up with a standard with an OWL and RDF, I think that's where it all started. On a bunch of text in there, but nuggets of knowledge in there, and that nugget of knowledge can change based on which domain or what you're doing that day.
Yeah, it has been an interesting journey. I remember back when the W3C really came up with those standards and people started adopting triple stars and RDF graph stores, that the performance and the kind of enterprise capabilities just wasn't there right out of the gate. So a lot of that excitement really faded. But if you look at the last 5-10 years, the evolution of taking this technology and making it, highly performant so that this representation of knowledge and the data around it can be scaled up into the, tens, hundreds of billions of records, as well as the instantiation becoming much more commonplace so that there's a lot of common ontologies out there for people to get started with, has really increased the adoption. So while that really was a great starting place all the way back there when the W3C came up with the standards, I think it's been probably only the last 5 or 10 years where that started to become reality for a lot of companies, and they've really been able to put it in place. Look at adoption of this type of technology, the adoption of the graph and NLP. One of the biggest struggles that people have been going through is, how do I connect my data in order to leverage this type of technology? That creating yet another data store within the organizations where they've already spent millions of dollars in order to be able to build up these large data warehouses and data lakes, and go, well, get lots of really great insights by leveraging the graph, but you're going to take everything out of that and stick it all into another repository, is kind of a bitter pill for people to swallow. And so that's why we really invested in trying to build this data virtualization capability directly into the platform, so we can represent data within from its existing silos within the graph, so that people can write graph queries, they can look at graph embeddings, they can look at all the ways they can leverage data through the graph, but don't necessarily have to do all this kind of extract and ETL and load and transformation into the graph itself. And that's been a huge help in the adoption, especially as it relates from the kind of ingestion side. But what I think is interesting is we've seen a lot of evolution on the consumption side, people consuming out of the graph. And one of the ways that I've seen that really change recently has been the idea of looking at natural language as a way to interact with the graph instead of a more structured query language, sort of like Sparkle or SQL, but people wanting their end users to be able to ask natural questions in the English or language that they're used to using, and then being able to get consistent or coherent or related pieces out.
That tells you that people are now looking at the other side of things, right? So if there was data or other semantic data that was not in the graph, then nobody would ask, how do I query it, right? So if somebody says, I want to query, it means that they did something to get semantic data in there, most probably using some kind of a conversion like NLP to take the unstructured data, convert it into semantic structured data. So now their question is, okay, now I have all these pieces. What do I do? How do I query it? What can I do with it? So usually our pipeline, our implementation pipeline starts from ontology development. You create the shape of the knowledge that you want. You create the important concepts that you're looking for, the important relation between those concepts that you're looking for, and then create that into a formal structure, usually an owl ontology. With that, just like how you have this virtualization process where you can take this, the legacy data, and without having to bring it in, you can still connect to it. Similarly, we have a process for taking the ontology and automatically training the NLP, because it's very hard for people to create an ontology. The ontologists sit and create an ontology, and then we tell them, you know what, the same piece of information now, train the machine as well, right? There's no reason why the ontology cannot be used directly to create or train the NLP.
When you talk about logical reasoning or inferencing, the ability to create connections between entities that don't naturally have keys or aren't naturally connected, that's been a critical feature of our customers as well, regardless of whether they're leveraging data that's extracted from natural language or from structured sources. Yeah, we've adhered very closely to the W3C standards as it relates to owls. So we support all of the levels of owl axioms that are specified, as well as the swirl language, which is the semantic web rules language, in order to be able to actually create and define these inference rules, to be able to structurally look at, this item is hierarchically a subclass or subversion of this other item, and I can then inherit that up, like Texas is a state of the United States, or by able to say explicit rules like if I work at a certain hospital and I am doing a study on a particular disease condition, then I can be considered an expert on that disease condition. Being able to define these rules is a way that a lot of our customers get value out of the data, beyond just integrating all the data under a single flexible platform. But now, like you said, creating these linkages where I don't need to kind of follow my nose through 10 different connections, but rather I can create the rules that allow me to jump right to the answer. And it makes sense that that's a critical piece at looking at it as it relates to natural language. When we see people look at inference rules, a lot of times they're using this technology for some sort of discovery process, right? Mm-hmm. They're using this to try to put out in the field within their group of people that are leveraging the technology to ask questions that they may not know the answer to, like risk analysts or clinical researchers, or maybe people who are doing financial investments, and they're trying to find a better way to mitigate the risk and look at the financial world in order to understand that better, all the connections between the various companies.
Mainly in communities that have a lot of unstructured data, which is pretty much everybody now. But mainly, let's say in the financial domain, related to compliance, what we see is there is a regulator that is coming up with all these different regulations that people are supposed to comply with, organizations are supposed to comply with. The organizations themselves have created policies and procedures to comply with those regulations. A lot of use cases that we have is related to the matching of this. Like a company would say, I have this policy and procedure. Do I comply with the regulation that the regulatory authority has come up with, right? And which parts of my document complies with that? We need to make sure that the NLP can extract like I said, the schema, right? The important concepts there, important concepts from the regulatory document, as well as the actual policy and procedure, and then do a match as well. And that is the querying part of the report creation part. With this, there are several new components or NLP components that come into picture. One is the extraction of entities. That's been very key, and the extraction of relations between concepts, between the entities has been key. Not only that, it's also about topic modeling, like talking about all these documents, what are they about, right? What's the aboutness of a particular document? The main reason for that aboutness creation or understanding is because people do not use the same terms for all the time, right? So you need to have new mechanisms of saying all of these are in the same domain or close to each other. They talk about the same thing. That's the aboutness of this particular topic. They're related somehow. and use that. To answer your question, yes, it's been all about document extraction of entities, relations, and then some kind of an application. Either it can be question answering to question about a particular entity and relationship between those entities, or it can be for report creation as well. So that's where we have seen a lot of interest in NLP in the recent times.
Yeah, one of the interesting things that I've noticed is how all of this technology plays with the kind of rise of machine learning and AI, right? So many of the organizations I talk to have built large data science orgs. They're always hiring into it. They're trying to find new techniques in order to better predict their business, their sales, the behavior of their customers, and be able to leverage that information in a way that will help the business. And one of the things that we've noticed from our side is it relates to leveraging semantic technology in order to help that is really that initial data acquisition piece. So when you talk about being able to bring together data from lots of different sources and represent it in a consistent way that it can be fed into an ML model, that's where we've seen people leverage the graph in order to tie together using the data virtualization we talked about earlier, using the semantic ontologies in order to rationalize the meaning of various objects and show the connectedness to be able to get more insight out of these models.
It's helped a lot, and then it has also harmed a lot in a way, because there is this preconceived notion that, well, deep learning especially, right? You have all these deep learning models, I apply it and it works. It does not happen that way, unfortunately. But that said, people have tried. Organizations have tried. Each organization now definitely has a data science team, has even a machine learning team to do some kind of a learning. I think where they hit a roadblock is the data requirement. Everything requires labeled data, and creating labeled data is expensive. So one of the key things that we have been working on is bootstrapping that process. We understand that if you have a lot of labeled data, you cannot beat machine learning techniques in doing either classification, extraction, question answering, anything that you want to do. But that said, label data is expensive. So we have a bootstrapping process. We start with small amount of data, just need a little bit of semantic annotations that you need to do. We can train the machine adequately enough that you can get your 70%, 80% there. And then as you collect that, they can try the system, help the machine learn more. And that's where the machine learning models come in. So this has been the message that we've been communicating quite a bit right now. So like I said, it's helped a lot because people are definitely open now to say these applications are now possible. These are not just wild science projects, that somebody just dreamed up. So these are some things that are actually conceivable now as working in practice.
Yeah, I've been in this space for many years now in a variety of different roles, usually from an analytics perspective. And to see the rise of machine learning techniques being brought to bear and the missed expectations has been quite interesting or quite amazing. We certainly have a lot of expectation setting that we need to do with our customers, that I've had to do over a variety of years with our customers, about how it's not magic, right? There's a lot of work that goes in related to building out these machine learning models, and a lot of work that goes into being able to get those predictions at a place where it makes sense, right? And it logically fits into the world. They don't just kind of erupt out of nothing. There's a lot of labeling of data that needs to be happen, rationalizing of data that needs to be happen. For things like just classification of information and be able to improve data classification, data prediction, similarity modeling, et cetera. But that, I think, brings up an interesting topic, and that's really what are the things that are kind of fantastical now, but we see the world heading to? Like, where do we see this space evolving? And I'd say on our side, there's really two things that are not there yet, but are things that are coming soon, which is Lowering, the first one is really about the ease of use. This has been a space of experts for quite some time, where we're
Mhm.
talking about ontologists and linguists and people that need to be involved that deeply understand how these things are structured and created and put together in order to get the most value out of it. And more, I've seen automation coming at being able to onboard new data sources, to be able to do some of like that initial training, like you talked about. None of it's there yet, but there's more and more innovations happening in order to accelerate that, as well as new concepts like data fabrics that are starting to talk about how do I take my entire data integration and access plane and hide it behind a semantic technology where I can use a single canonical model in order to interact with data regardless of where that data lives, regardless of whether it's structured or unstructured data, to really simplify the citizen analyst's role or the application integrator role throughout the organizations. Most of these are pretty early stage, but we do definitely see the market still continuing to evolve and continuing to innovate in this space. Well, Mithun, it's been great talking to you today. I look forward to in the future digging into some of these topics deeper. I think that we can have some great conversations around ontology development and other ways that this technology has been adopted, use cases, et cetera. So